Hi, everybody. Welcome back to Dave's Math channel. I haven't made a math video in a while. I've been pretty busy with a lot of other stuff, including campaigning for Harris for president. The election is just 4 days away, and probably going to keep doing that until the election because I just want to do everything I can to make sure she wins this thing. I really think she needs to. Anyway, enough of that. But let's get back to math. So today I decided to start a new category, namely logic. And there's a lot of interesting seeming paradoxes in logic. I don't think there's any actual real paradoxes in math or in anything really. I think there's a resolution to every paradox because I just don't think you can have a world where A and not A are both true. That's Aristotle's law of the excluded middle. I do believe that. But just one example of a seeming logical paradox is this thing called the Berry paradox. And it's a pretty simple paradox. So imagine you want to try to find the smallest natural number that can't be named in less than 14 words. Well, you would think that such a number would have to exist, right? Because there's infinitely many natural numbers, and there's only a finite number that can be expressed in less than a certain number of words. I mean, that just seems kind of obvious, right? But the problem with that is if there was such a number that couldn't be expressed in less than 14 words, then we've expressed it just by this sentence. This sentence has just 13 words. So whatever the smallest number, natural number is that can't be expressed in less than just 14 words, we've already done so. So that's a paradox because this number can't exist. At least it seems like a paradox. So how do we resolve this? I mean, how do we make sense out of this? Well, it's actually pretty easy to do so. The problem with the Berry paradox really stems from the fact that the English language isn't really that precise. I mean, whenever you're making a mathematical definition or you're trying to describe some exact quantity in math, like a natural number, then you have to make sure that you're defining everything precisely, pinning everything down. And the problem with English is it doesn't really do that. I mean, we have to define each word in our sentence really precisely. What do we mean by name? The name of a number. I mean, here's a sentence again. Let's just go back to it. The smallest natural number that can't be named in less than 13 words. So named is just a kind of another way for defining a number. But then you have to be precise about what you mean by defining. How do you define a number? What rules do you have for defining a number? You have to specify the rules. Can you define as an English sentence? Does this sentence itself define the number? Turns out it doesn't because there's a self reference problem in this. And there's other problems as well. I mean, we haven't really specified what we mean by a word can't, cannot. I mean, contractions, a lot of contractions are two words combined into one. Do we count them as one word? And what if I mean this sentence doesn't have it, but what if the sentence had a number in the sentence? Do we count the number as a word? I mean, we have to be very precise by everything we're talking about in this sentence, and unfortunately, we're not really, just because of the failure of English to do so. But there's another problem that's going on with this paradox, I think, and that's the problem of self-reference. I mean, you got a lot of seeming paradoxes resulting from self-reference, and I think the oldest of these is the liar paradox. I think most of you are probably familiar with this one. This sentence is false. Is that true or false? Well, let's assume it's true. Well, the sentence itself is saying it's false. So if it's true, then it's false. What if it's false? Well, then it's saying a truth. It's saying a true statement that the sentence is false. Either way, you get a contradiction. So I think what that means for the liar paradox is that you can't assign a truth value to every sentence. I mean, the sentence can't refer to itself. And I guess you can have truth values that aren't necessarily either true or false. The sentence obviously can't be either true or false. You get a contradiction either way. And then there's also Russell's paradox, which is kind of closely related to this one. That's the barber paradox, I believe. You have a town where everybody, they have a barber in this town that shaves everybody that doesn't shave himself. Well, that's impossible because then who shaves the barber? If he shaves himself, then he doesn't, and vice versa, kind of like the liar paradox. This is a paradox, pertaining to set theory. You have to be very precise about how you define sets. There's a thing called naive set theory that has this problem. The problem results from, just if you define a set to be any collection of objects, that doesn't work. That gives you a lot of paradoxes, including the Barber paradox or Russell's paradox. And there's also, one of my favorites is the interesting number paradox. I think it was, I'm not sure, but I think it was Ramanujan who came up with this paradox. He said that he had a proof that every number, every natural number, is interesting. It's pretty easy to prove, and it's a lot like the Berry paradox. So suppose suppose that not all numbers are interesting. Not all natural numbers are interesting. Well, what's the smallest number that's not? Just an example, say 73 doesn't seem like a very interesting number. Well, it's the smallest not interesting one. That makes it pretty interesting, wouldn't you say? Kind of like the Berry paradox. You have to, specifically define what you mean by interesting. So, anyway, those are just some examples of some logical paradoxes resulting from self reference, which are kind of fun. And, this is a short video. I didn't want to go into detail on any of this stuff because I haven't done this in a while. Like I said, been pretty busy with a lot of other stuff lately. Maybe things will calm down once Harris is president. Anyway, thank you for watching. Long live math, and I'll see you guys next time.